Going to the smaller terminology, circle geometry terminology booklet, we're looking at circle theorem number 3, and that theorem states that the angle at the center, so this is the angle at the center, is twice the angle at the circumference subtended by the same arc. See how they're both subtended by arc BC. So I can move this around. So the angle at the center is twice the angle at the circumference subtended by the same arc. If I change this angle in the middle to 100, angle at the center is 100, angle at the circumference is 50. Angle at the center is 134, angle at the circumference is 67, etc. Angle at the center is 48, angle at the circumference is 24. So we can see that. So let's just write that in our booklet. Angle at the center is twice the angle at the circumference subtended by the same arc. In other words, if this is theta up here, then this is 2 theta. Now, we're going to draw the 3 unique cases of this theorem. So you're going to need 3 circles. But I'm going to show you on GeoGebra the 3 ways that this can look, okay? Just the ordinary way that we've seen, like this. Okay, which is what's drawn there. The other way I showed you, I think, wait, bring this one around. I could swing them all around down here. So you can do the reflex angle in the center. See how the reflex angle in the center, see, angle at the center, 250, is twice the angle at the circumference. And wait, I'll just show you the, all right, we'll just go back to our sheet and draw that in. So we've got, the first scenario is as you can see it up there. So here's my center. Angle at the center is twice the angle at the circumference. That's the first one. Then we've got the reflex angle situation, like this. The angle at the center here is 2 theta, and this is the angle at the circumference, theta. So see how they're both down, like this and like that. And they're underneath what I'm drawing. There's my angle, underneath this angle, underneath this angle. This angle, that's sort of above it, I suppose, or you would turn your page over. If I turn my page upside down, look, that's under that angle. This is under that. You can't have one in and one, they've both got to be underneath. You can't have this other one inside and that one there. All right? And the last situation is, or the last case, second scenario. Now the third one is as follows. No, that's not right. One sec. 94 and 47, or I can go 90 and 45, for example. Once this, once say DC sits on top of AC, it can look like that. You see that? So that's like that, but when I draw that over there, or if I put DB on top of the other one, it doesn't look like, so angle at the center, angle at the, and angle at the circumference. So you can see that they're still subtended by the same arc, but I'm just drawing one of the arms of the angles on top of the other arm. So I've got angle at the center is twice the angle at the circumference. They are both subtended by arc BC. So when one of the arms of the angle sits on top of the other is the third scenario or third case. Drawing that on our sheet, you've got the angle at the center there, and and that's a straight line. And this is, so this is 2 theta, and that's, so girls, that's a diameter there. And that one's theta. Angle at the center is twice the angle at the circumference. Subtended, yes, and I could do it the other way as well. Over the other side as well. Okay? It can look like this. Like that. So I can change some sizes. There we go. That's the other case. The angle at the center is twice the angle at the circumference subtended by the same arc. Can you see that? So I could draw it on the side next to it. So maybe on our sheet, if we go back to our sheet, why don't we just change this first one, because the first one is like that. Do you understand? So let's just fix this one up if you've got no room. That this can appear if this is my center is that that is 2 theta, and say over here is theta. So the angle at the center, that one there, is twice the angle at the circumference, subtended by the same arc. They're both subtended by this arc.
Could the lower
Arc, say AB. So AOB, ACB. So I'm going from there and from there. You must start and finish at the same point. That's how they're subtended by the same arc. So for example, angle AOB equals 2 times angle ACB. Do you get that? I can do that here as well. AOB. You would say here that reflex, got it? Angle AOB equals 2 times angle ACB for this one. Do you get that? That the reflex angle. And this one again, angle AOB equals 2 times angle AOB equals 2 times angle ACB. See, and they're standing on arc AB. This is standing on arc AB, and that's standing on arc or subtended by arc AB. So all these are subtended by the arc AB. Now, this is subtended by the minor arc AB. The last one is also subtended by the minor arc AB. But you know this is arc AB, and so is that. This is subtended by the major arc AB. It's standing on the bigger arc AB, because you can go from A to B 2 ways, this way or this way. That would be the major arc, that would be the minor arc. Do we get it? Okay, so this is subtended by arc AB, but this is by the major arc AB. This is the minor arc AB. You don't need to say minor. In this one, it's just the normal arc AB. That's also AB. But this is subtended by this arc. Not by this arc, otherwise I'd be going that way. No, it's this way. Especially, you can see it with this one. It's harder to see that one. All right? If it's subtended by that major arc, you come this way. You always go away from the arc. Do you see? You always take your angles away from the arc. From the arc to the center, from the arc to the circumference. From the arc to the center, from the arc to the circumference. Here, from the arc to the circumference is easier, but they've got to be both on that side. See? These are both under there. That is under there, under there. You can't have one in, you can't have them facing each other. Like you can't have that with this one. Yeah. Is twice the angle at the circumference. So I've got angle at the center, angle at the circumference, points A, B, C, and the center. We are going to join. We are going to join AO and produce 2D. Then we're going to let angle. Now, if you want to end up with the one at the center being double, we should let angle BAO equal maybe X and angle CAO equal Y. So angle BAO equals X and angle CAO equals Y. Okay, what do you think we can do here? What have you got? What sort of triangles maybe? Let's just play around a bit. I'm going to work in a different color. What do you think you could do? Well, it's definitely what sort of triangle? Girls, what sort of triangle? That's a radii. That's a radii. Yep. So if that's Y, what's this? Base angles. So I know that that equals that, which equals that, right? Wait, let's just draw it all. That's Y. So this is Y, base angles of isosceles triangle. If that's X, what's this? X. What's this angle in there? By angle sum of triangle, what would that angle in there be? Minus 2x, good. By angle sum of triangle, what's this angle? And by angle sum at a point, let's work out what the middle angle is. Minus 180 minus 2y minus 180 minus 2x, I think gives you 2x plus 2y. So therefore, This is x plus y, and that's 2x plus 2y. So that's the way we're going. So let angle BAO equal x and angle CAO equal y. We know that AO equals OC equals BO, reason, equal radii. So therefore, triangle, so I'm just going to go, so therefore angle OAC equals angle OCA equals y, base angles of isosceles triangle, got to say y. Oh, well, I did say that they're equal. Oh, and I'll put OA equals OC, right? And angle BAO equals angle, which one are we doing? OBA equals x, again, base angles of isosceles triangle, OA equals OB. We keep going. Remember, we're doing angle AOB is 180 minus 2x. Reason? Angle sum of triangle AOB. Angle AOC is 180 minus 2y. Reason? You know, actually, I've got a better idea instead of that. Don't have to do that. There's a quicker way. What's the quicker way? Getting rid of that. Sorry. Quicker. We could do it, but there's a more direct method. I'll hint. Angle DOC equals 2y. Very good. So angle DOC equals, I can actually spell it out, equals angle OAC plus angle OCA equals y plus y, which is 2y. Reason? Exterior angle of triangle equals sum of the two interior opposite angles. And also angle DOB equals angle ABO plus angle DAB, which is x plus x, which is 2x. I'm just going to go similarly. Same reason. All good? So instead of doing those 180 minuses, which we don't need, you know, I know this takes a bit of time too, but it's good to practice the exterior angle of triangle. That's 2y and 2x in there. So I might just come up here. So therefore angle BOC equals angle BOD plus angle DOC, which is 2x plus 2y, which is 2 lots of x plus y factorized, which equals 2 times, and we can also spell out that angle BAC equals angle BAO plus angle CAO, which is x plus y. So therefore angle BOC equals 2 times angle BAC. Feeling okay about that?